Okay, here we are. We're doing Immunology 6. I've titled it How Vaccines Work. So we're going to have a little discussion about when you inject a vaccine into an animal, let's say the rabies vaccine, because I've got some data on the rabies later. How does it work? Well, it can be very simple, simply explained, or really difficult, or complicated. Let's look at this diagram. I found it on the internet. It's listed back in our illustrations. When you do inject a vaccine, I'm reading over here now to the left of my black writing, a weakened or killed form of the disease is injected. Another way of saying that is an attenuated or modified live or killed vaccine is injected into the animal. And remember, this is antigens, right? The vaccine is antigens. You got to make sure you don't think vaccines are antibodies in the needle. Nope. They're antigens. They're weakened, they're killed, they're injected into the animal. Sometimes they're given in the nostrils, sometimes in the drinking water, depending on the animal and the situation and all that. Now the middle panel says the body creates antibodies. Remember, antibodies are always Y-shape. And this is true. The body creates antibodies. Well, that's one of the responses. We're going to find out some memory cells are made too. Then in the bottom panel here, if the animal is ever exposed to the disease, like let's say rabies. We had a dog vaccinated for rabies, let's say, and then the animal gets tangles with a skunk. The dog fights a skunk, and the skunk has rabies. Then it says if the actual disease germs ever attack the body, the antibodies return to destroy them. I don't like that term return because they're in the blood already, and then there's memory cells that can make more. So the return word there bothers me a little bit. But, the return from the previous figure bothers me a little bit. But everybody explains it differently. We're moving on. Now I'm going to enlarge this and walk you through it a little bit. Here's another explanation of how vaccines work. I'm way over here in the far left. The vaccine is delivered. A lot of times injection, a lot of times not. The red circles, spheres here, are the antigen. Remember, the vaccine contains antigen. It might be modified live, attenuated, killed, and it might be what's called multivalent. It might contain different kinds of antigens. Okay? Nonetheless, there's a cell called the antigen-presenting cell that phagocytizes it and digests it into little parts. Some of the famous antigen-presenting cells are called dendritic cells, and then another one is B cells, and then macrophages. So maybe I'll pause here at the end and spell those out for you. Nonetheless, these little fragments then are presented to T helper cells that go on and say, hey, Mr. B cell, start thinking about making antibodies. Whenever you see the word naive means I haven't seen that before. Okay? It hasn't been delivered by accident or by vaccine. On the lower panel, you have naive, what they're calling killer T cells that are going to be activated, and you might want to call those killer T cells, what they're saying is, more people call them cytotoxic T cells. But again, there's a lot of terms that can be applied. B cells go into more mature B cells, and they're called plasma cells, or you could call them plasma B cells, but it's better just to say plasma cells. They're going to actively make antibody. thousands and thousands. And then they don't really show it right here, but the antibodies, I guess maybe they have that short Y. Remember, it's not the long part of the Y that binds to the antigen, it's the shorter part anyway. So anyway, got antibodies and it's going to neutralize it. Down here, the cytotoxic T cells will actually destroy infected cells. Now, what do you end up here? You have memory B cells, you have memory T helper cells, helper we're back here, and then memory cytotoxic T cells. So you have antibodies floating around in the blood after vaccination, we'll show you that, and you have these memory cells. The memory B cell can go on and make more antibodies. And on the bottom there, I spelled the 3 most common antigen presenting cells. A lot of times in books you'll see APC, antigen presenting cells. So dendritic cells, B cells, and macrophages, because you might get confused, but some cells can do multiple things. Anyway, dendritic cells are probably the most powerful antigen presenting cells. Now, the last two figures have gotten more and more complicated. The first one was too simple, actually. The middle one, the last one we just saw, wasn't bad. I show you this one. I'm going to enlarge it here in a little bit. I show it to you to show you how complicated it is if you talk about everything. Let me enlarge it. And let me do the top panel first, because the top panel over here says the immune response to a vaccine. This is when you first get it. It's not really different than the other one. The writing is too small to even study it. That's okay, because we already said the important things, but you might want to pause and see if you understand what's going on with this top panel. Then I'll move it up, because then this bottom panel says what happens when you get exposed to it after you're already vaccinated. So if you're already vaccinated, then you'll see these memory things pop up, and you should know that from the last slide we had. So that's a very pretty graphic. The bottom line is there's memory cells made, and antibodies are going to be floating around in the blood. So now I want to focus on the antibodies in the blood for a while, because that's a very important response you get, because the antibodies can be found in a lot of body fluids, and they attach to antigens that they're made against, of course. And this is going to be a little fuzzy, but we can do this. Down here on the x-axis, this is time. Time increases to the right. The first time you get exposed to an antigen, let's say it's the first vaccination. This is the second vaccination. Then the lines are referring to IgG and IgM. Okay, and then titer is on the y-axis, and I'm going to talk about titer a little bit, but basically the higher you go on the y-axis, the better the response. So primary immune response is the first time you saw something, and you get a little blip for both IgM and IgA, but they kind of come down. But the second time, notice you don't get an immediate response. There's a little lag time. See where my red laser pointer is? You inject the second, you might call it the booster. It's not immediate jump, but you get some IgM, but now we've switched over to a lot of IgG. So that's the hallmark of a secondary immune response. You get much more antibody, and they tend to be more IgG. So let me move that one out of the way. And this figure, it's a little clearer, but it talks a little bit different. Here's weeks. X-axis, usually when you look at titers, always, well, when you look at animal response, time is on the x-axis, titer is on the y. Here is, if you give antigen A at this point, you get a response, antibodies that will recognize antigen A, but you don't get a response in any other antibody production. Okay, so that's why this blue line is low, because you don't get a whole bunch of antibodies that recognize a lot of things. It's only going to be recognizing antigen A. Comes down just like the other one showed us. Now here's the booster. Now when you get a booster after you've already had one, then you get a much bigger response. They're not saying it's IgG, but it is. And then antigen B was given in the same vaccine. See that? There's two antigens in the vaccine. You get a response, but it's the primary response, just like this. Primary is like you've never seen it before, and you haven't. You didn't get the antigen here. So you got to remember, just because you vaccinate an animal for one antigen doesn't mean you get antibodies for other antigens. That's the take-home message here. It's very specific. If you vaccinate a dog for rabies, it's not immune against parvovirus, for example. Now, titer, I just want to talk about it a little bit more. It's kind of a way to express the concentrations of antibodies in a blood. And there's a couple figures here, and you can read this whole thing. You can do tests to see the titer. And the titer is always done on a dilution. So I'm up here in the top here where my red laser is wagging back and forth. Something was diluted 1 to 20, then 1 to 40, then 1 to 80, then 1 to 60, then 1 to 32, 1 to 640. A lot of times there's controls. The other one has a positive negative control. And wherever the reaction, the last reaction takes place, you look at that number, that test tube. See, happens to be agglutination. Down here you can read that. The last time it agglutinated, you would say that was at the dilution of 1 to 160. But when you say the titer, you do the reciprocal. So you would say the titer from this animal sample is 160. So you say 160, but everybody knows you did the reciprocal of the highest dilution that yielded your endpoint. Okay? You can pause that and read it, digest it. I'm moving it out of the way. This one shows another titer determination. Got different patients listed here, and then the serial dilutions going this way. And the dilutions don't always have to be perfectly double, like 1 to 2, 1 to 4. This one happens to be halving all the way. So for patient 1, this agglutination went to 64, 1 over 64, but then it didn't go any further, so their titer must be 64. And look at, they've listed it over here. Here's the positive control. That means you should see agglutination in all of them. And then you have a negative control, because usually when you do biochemical tests, you have controls that say, my test is working. Then let's look at patient 3. Wow, a titer of 1 over 512. So the titer is 512. So in this case, that person or animal has a lot more antibodies for the disease than, let's say, patient number 8. They didn't get very far. The highest dilution that yielded their endpoint was 4. Okay? So not well immunized, not a good response to whatever they're vaccinated against. 3 was an excellent response. So this brings up this discussion. Different animals respond differently to the same vaccine. Why would that be? Well, if the animal is sick, immune responses are low. If they're not properly fed, their responses will be low. Sometimes animals get vaccines that haven't been handled properly. Maybe the truck got hot between here and Iowa, for example. Maybe all the vaccine that's unloaded that day is inactivated, but you don't really know it. Another good reason for, very common reason for vaccination failure. What I mean is you vaccinate an animal and it doesn't give a response, titer-wise. The presence of maternal antibodies. If puppies are vaccinated for a disease too early, the antibodies they got from the colostrum and across the placenta in the dog, right, are going to grab onto the antigen and not really let it interact with other cells. So the presence maternal antibodies in young animals is probably the most common reason why vaccines fail, a vaccination response. A lot of good reading on that. Somebody maybe didn't handle the vaccine right. Somebody used a needle that wasn't clean, and whatever was in it inactivated the vaccine as it was being injected in the animal. Oh, all kinds of stuff. Now we're going to talk about herd immunity. You might say, I don't have any cows, or I don't want to talk about cows. No, herd immunity is a very generic concept. It's used in humans, dogs, cats, you name it. Herd immunity. And what this is referring to is how many animals in a population are vaccinated and protected. If you don't have very many animals vaccinated, then when a disease does come, most of the animals are going to die. The ones that are not vaccinated. If you have some, in this figure I'm going to show you this. If you have a lot of animals vaccinated but a few aren't, even if one gets sick, it won't spread even to some of the ones that aren't vaccinated. It's called herd immunity. So, why does my choice matter to others? I can't remember where this came from, but this has people in figures, but think of it as dogs. Okay, so let me orientate you. The blue, they're not immunized, but they're healthy. Okay, and in this case, a lot of people aren't immunized, but they're healthy, but we have two red, and that means they're sick and contagious. Well, they're going to spread it to all these blue people, dogs you can think of. So if no one's immunized, disease spreads through the population, and red is diseased. Okay, so, but some don't. You can have some individuals exposed to a diseased person and they don't get the disease, but look at almost everybody got sick. Then when you have a lot of blue, but you got the gold, and the gold are immunized, so they're protected, they have antibodies. Well, then you have some red that's sick and they're not immunized. It can still spread, and you end up getting a pretty good population of red, that means sick. But down here at the bottom, the take-home message is the gold is immunized and healthy. When most of the population is immunized and healthy, even if you get some of these sick people, even the ones that are healthy but not immunized often will not get the disease, because look at, you can't spread it that far. This person, if it touches that person or coughs at that person, that one's protected, that's protected. So the susceptible animals are spread around. So the bottom line is over here on the right, you did get one more person or dog sick, think of it that way, than the original two. There's two over here, now there's three. But even the ones that weren't immunized were protected. Why? Because they were protected by other people not spreading it to them. That's the whole concept of herd immunity. And I think the number varies, but I've seen books say 85 to 90%. If 85 to 90% of the population is immunized and healthy and has a good immune system, then disease is likely not to spread through that population. Because even some of the animals that aren't immunized won't be exposed to the disease, because most dogs are vaccinated. Really important concept, herd immunity. Now, I was talking about rabies a little bit as my example, and I do have a couple figures here. Okay, well, I found this someplace. I think this is from 2009, as it says there up in the upper right. And this is the number of cases of rabies by state. And this is not people, this is all animals. It's not just dogs and cats, because I know in 2009, the same source said there were about 300 rabies cases in cats and about 100 in dogs. So about 400 cases of rabies in the dog and cat population. So if you look at this, this must be all the animals that were diagnosed, the wild ones as well, because Texas has 830, so that's way past my 400 number. But you can kind of see this is the number of rabies cases, so it'd be skunks and raccoons, and who else knows what the numbers are. What's interesting in the United States is, of course, there's laws that you have to vaccinate your pets, and of course consult with your veterinarian about how often and what ages are appropriate and all that. I don't do any of that recommendation. I'm not qualified to do that. But you should be aware that in the United States, we've done such a good job of vaccinating overall for rabies that only 1 or 2 people die a year from rabies, okay, in the United States. But you know, in the whole world, over 50,000 people die from rabies every year. So we are really fortunate. And I did find a graph figure that talks about those 50,000 or 55,000. And it starts out by talking about India, and I'll just blow it up here a little bit. And it talks about 20,000 people in India die each year of rabies. And I remember years ago when I was in school, I saw a film of somebody in India die of rabies. It was terrible. It was a village that had been attacked by rabid wolves in, some remote population, and it was actually an army training film to show you the signs of rabies in a person. It wasn't pleasant to watch. Well, it looks like they have quite a large stray dog population, 25 million. There's a lot of biting going on, and I don't know, it doesn't say how many of those dogs are vaccinated, but probably not many. Okay? So anyway, 20,000 in India, but the whole world is about 50,000 people die of rabies every year. And I'm going to show you the list of those fine illustrations, and see you next time. Take care.